Come on. There we go. So when we simplify y in the numerator, y in the denominator, what do we have left? Thank you. Y to the third power. So let's do one more. How about m to the fourth power divided by m? What's the power on m if we don't see it? 1, right? All right, so now, simplify here. What does this expression simplify to? What's m to the fourth power divided by m equal? M to the third power, right? So let's look and see. 6 to the seventh power divided by 6 to the third power is 6 to the fourth power. Y to the seventh power divided by y to the fourth power is y to the third power. M to the fourth power divided by m to the first power is m to the third power. Do you see a pattern, McCoy? We can just subtract the exponents. It's exactly what we're going to do. So where our shortcut for multiplying like bases is to add the exponents, the shortcut for subtracting them, for dividing them, is to subtract the exponents. Exactly what we're going to do. We don't want to have to do that every time, right? So it's not always just going to be one variable by one variable, though. Sometimes there's going to be more than one variable. Sometimes there's like bases, sometimes there's not. Let's do this one. Let's use the shortcut. We have like base, right, x and x, like base, y and y. So I'm going to give a couple of steps to make that x to the sixth power minus the second power. It's always, so we're dividing top divided by bottom, so when we subtract, it's top minus bottom. Does that make sense to everyone? So x to the 6 minus 2, y to the 9 minus 4, sorry, 5. So that simplifies to x to the fourth, y to the fourth. Someone asked in first period, will they always have the same exponent? No, they won't. It just happened to be that we had, we divided and the exponents happened to both be 4. Does that make sense? Everybody caught up with me? Okay, I think from here. Oh, while I'm thinking about it, let's go ahead and fix your homework so you can read it. Notes, not all the notes, but I don't want to forget the problems if you have 4 or 5 problems that you can't read. I actually thought I had it open, but alright, I'm going to make it bigger so you can see it. Maybe. Oh, yeah, we're good. Oh, nope, you can't see. That's the problem. When it switched to the PDF, it messed it up for some reason. Alright, I took the odd ones off for you guys, so I'll make this bigger so you can maybe. So I think 8, 10, and 12 on the front page are the ones that are hard to see. While I'm thinking about it, if you look on Canvas right now on the home screen, I think it says we're going to do 3 days of review for this section and then test. on Tuesday, but this is the last news section. We'll spend another day on it tomorrow. The last news section before our test, rather. I think it's just going to review 2 days, which means we test on Monday. So that is the plan going forward. I am going to talk with Coach Norman because we do try to keep in the same schedule, but I think 3 days is too much to do for this section. And that might allow us to test before we go to Thanksgiving on the last part of this chapter. Either, are you writing the problems where you can read them, buddy? You can't read 8, 10, 12, and 14 on your worksheet. You have to write them in. Sorry? Yes. He teaches 1B and Algebra 1. I teach Algebra 1B and Math Data Science and Literacy this year. We are married. We've been married, we've been married 34 years.
Oh.
Y'all can read 14 though, right? 14's good? I can give you another second or two, and then I'll come back at the end for you guys who started late. We're going to go back to number 26. You can't. Oh, actually, you know what? We're not going to do number 26. Just scratch 24 and 26. I changed my mind on those two. You're doing everything but 24 and 26. Okay. Which one in the back or front? And you can read the ones we're going to do in the back. Did you notice in the board first period? On the whiteboard, I should say. Not. Sorry. Y'all caught up? You have all copies, you can read them? And then you evaluate the exponent. Okay, so we are going to go ahead and keep going with our notes. So let's go ahead and put example 1 in our notes. X to the 10th power divided by x to the 2nd power. What do you think that's going to simplify to?
X to the 8th.
Yes. So it would be x to the 10 minus 2 power, which is x to the 8th power. Remember, when things, so your directions typically are going to say simplify the expression. So we're always going to do powers first. Then we're going to do any multiplying in the top and multiplying in the bottom. Then we'll do our dividing from top to bottom. And then last but not least, any negative exponents get moved, right, to make them positive. All right. Y to the 3rd power divided by y to the 7th power. Give it a whirl. Y to the 3rd power divided by y to the 7th power.
Y to the negative 4th.
It is. But now, what we need is y to the negative 4th power. So this would be y to the 3rd minus 7th power, which would be y to the negative 4th power. But what are we going to do if it says it's a negative exponent? Rewrite it as a fraction and then move that, right? If it's in the top and it's negative, we move to the bottom, and that makes it positive. If we don't have anything left in the top, we replace it with a 1. Or replace a 1, I should say. Any x's and y's in the top, x's and y's in the bottom. Nothing to do in the top or bottom before we divide. So it doesn't matter if we have more than one like base in our fraction, we just work only with the x's and only with the y's here. So this would be x to the 6 minus third power, y to the 7 minus 10th power. I'm not going to make you show me this work, but I will tell you if you're not super comfortable with this concept yet, start by doing this. It will help you. And then when you get more comfortable, you don't have to do that step. So here we have x to the third power and y to the negative third power. So can we leave it like that? No, we cannot, right? If it was scientific notation, we can have a negative exponent, but not here. So we're going to make it a fraction, and then we're going to leave our positive exponents where they are and move our negative exponents. So what's the final answer going to be, Brandon? So not 3x, right? 3x would look like this, right? So how do we read that? The x is first, x to the third power. Yes. And what's going to be on the bottom, Brandon? Perfect. Y to the third power. Any questions on that one? Okay. Let's do this example. You guys try this one. Make sure you're working in pencil, that way if you mess up, you can erase. So that's a negative 6. You can't see that. Did you guys get this to start with? X to the 11th raised to the 11th, negative 11th power times y to the third power? Okay, so what's the final answer going to be? Yes, so it's got to be a fraction because that's going to negative. So anything with a positive exponent stays where it is. So the y to the third stays on top. X to the negative 11th goes to the bottom and becomes a positive. Any questions? Okay. Keep going. We are going to do example 5. So, this tricks some kids up, right? The 12 on the top and the 4 on the bottom. Remember, what's the exponent on the 12? 1. What's the exponent on the 4? 1. So they have their own exponent. They're not getting raised to the negative 2 power to the 3 power, right? So, what is 12 divided by 4? That's all you're doing there, okay, guys? So we're simplifying that to 3. So now we'll have x to the negative 2 minus 3 power, and y, this is y to the 7th minus the 5th power. So 3, x to the negative 5, y to the 2. So far, so good? Does that make sense, Nicholas? All right, so what am I going to do for Nicholas if I have a negative exponent left? Okay, what am I going to change it to? Other side of what? So what does it tell me if I have a negative exponent? Do you know, Jaden? What's it mean if you have a negative exponent? A fraction, yeah. So let's put that over 1. When we said, what's the exponent on 3 if we don't see it, Jeremiah? 1. So anything that has a positive exponent stays where it is. The 3 is a positive 1, so it stays on top. Y is a positive 2, so it stays on top. the negative 5 exponent, Nicholas? Where did it go? At the bottom. And is it a positive or negative 5? Yes. When we move it, it becomes a positive. Any questions? All right. Let's look at this one. Actually, I think we'll take that one. Let's do example 7. So put that one in your notes. Example 7. All right. So we always have to do powers and powers first. Then if we can multiply in the top, we multiply in the top. If we can multiply in the bottom, we multiply in the bottom. Then we do our dividing. Then we move our negative exponents. Okay? The first thing we're going to remember, this is not new. We've done this before. Let's remind ourselves that it's a fraction raised to a power, a positive power. That's the same as that numerator raised to that power, divided by that denominator raised to that power. So now it's like power to a power, but this is the tricky part. This is what some kids forget. What is the exponent on the negative 2 if you don't see it? 1, right? So that is going to be negative 2 to the third power. And because it was in the parentheses colon, you and I have talked about this a lot. That's negative 2 raised to the third power, not the opposite of 2 to the third power, okay? And now it's x to the first, so that's 1 times 3, 1 times 3. Everybody understand how we got negative 2 to the third power, x to the third power? And we're going to do the same on the bottom, but we only need 1 power. So power to a power, up high, multiply, will give me y to the 12th power. We don't have anything we can divide because we can't divide if they're not like bases, or if they're not numbers, right, coefficients. But we can't leave negative 2 to the third power here. So on our calculator, we're going to do 2 negative buttons, y to the third equals. So this here is negative 2, sorry, not negative 2, 2 negative buttons. So on your calculator, we're going to do 2 positive negative buttons, y to the x 3 and equals. Yes, you should get a negative 8, and then we just keep the x cubed and keep the y to the 12th. Any questions on that? That's actually not new. We've done this before, right? We've been doing this when we were multiplying. Put this one in our notes. So same thing here. If it's a fraction raised to a power, what's in the numerator gets raised to that power. What's in the denominator gets raised to the same power. And now we do them up high multiply, right? Don't forget, if you don't see it, it's a 1. If you don't see it, it's a 1. So that's going to be x to the 5th power, y to the 20th power, over 3 to the 5th power, x to the 10th power. I'm going sideways here because I'm running out of gray. The white only works in the gray. But We're going to simplify here. X, so the like bases are here. Oh, I wrote down the, I wrote a 10 to the 10. That should be X to the 10, right, guys? My bad. Come on. X to the 10th power. Alright, so that, like bases are x's. We have a y on the top and no y's in the bottom. We have this constant, or this coefficient that we need to raise to the 5th power. I'm going to start with x to the 5th minus 10th power. Y to the 20th, nothing to do with that. So I've taken care of those, I've taken care of that. Now I need to do 3 to the 5th power on my calculator. 3 y to the x 5 equals 243, right? Bigger than you think it would be. 243, but we can't leave this like this. That would be the negative 5. I'm going to kind of take a shortcut here because I'm running out of room. So now I have, actually no, let's not take a shortcut on what you guys do it. So, x to the negative 5, y to the 20th over 243. And then for our final answer, everything with a positive exponent stays where it is. Anything with a negative exponent gets moved. So that's in the top, so we move it to the bottom. So I'm doing a bunch of steps with this, right? And I would suggest you start with at least some steps. And the more comfortable you get, you can start cutting out a little bit of these steps in this work. But it's definitely in your best interest to show some steps at first. Keep yourself on track. Anybody have questions on example 8? Y'all caught up with me? And let's do example 10. Is that one in your notes? So now we have a fraction raised to a negative exponent. So we could be like we've been doing, and we could raise everything to that negative power. But we also learned when we started multiplying like bases that if it's a fraction raised to a negative power, we can flip the fraction, and that makes that exponent positive. So here, if we flip this, to the bottom and the top and the bottom, 2y squared over x to the 4th, y to the 7th, all raised to the 3rd power. It was negative, but when we flip it, it makes it positive. Now, could you have just raised the numerator to the negative 3 and the denominator to the negative 3? You could have done that, but you'd have had a lot more moving stuff around. Does that make sense to everyone? Alright, so now we're going to distribute, or rewrite as 2 minus 1 times 2 to the 3rd power, y to the 6th power. I want you to shortcut. Muggy dog. Let's do 2y squared to the 3rd over x to the 4th, y to the 7th to the 3rd. Now we can do the step that I just was doing. So to the 1st, that gives me 2 to the 3rd power, y to the 6th power, over x to the 4 times 3 power, or x to the 12th power, and 7 times 3, y to the 7 times 3, or 21st power. This is the 3, right? Right here's the 3, right? Right. I know it does because I wrote over it there, but yeah, it's a 3. So we can't leave the 2 raised to a power, and we have a y on the top and a y on the bottom, so we have to divide them. So what's 2 to the third power? 2 to the third power is 8, and we're going to do y to the 6th minus 21st. Remember, it's always top divided by bottom, so it's top minus bottom, or use your shortcut, and that's x to the 12th there. Now, I'm going to simplify 8 y to the negative 15th over x to the 12th. So what's my final answer going to be, Brooklyn? Brooklyn, what's my final answer going to be? Okay, so what's the exponent of 8, Brooklyn? So that's a positive. So do we move to 8? If it's a positive exponent, do we move it? Because that's going to go on the top. This is a negative exponent. We're going to move it? Yes. And is it going to be a negative 15 still? Positive 15. What do we do with the x to the 12th power? Is it a negative? If it's not a negative, we don't move it, right? So we're going to leave it in the bottom where it is. I'm going to put it first because we usually have it in alphabetical. Okay? Once we get to the end, anything with a positive exponent stays where it is. Anything with a negative exponent has to be moved. If it's in the top, it goes to the bottom. If it's in the bottom, it goes to the top. And we have one more example, if you've got one like this on your notes. So last one, I'm sorry, on your homework, 3.8 times 10 to the negative third power, put that in your notes. That'll be the last notes problem. 5.1 times 10 to the negative 2 power. So here, we're dividing. This is going to be the same as 3.8 divided by 5.1 times 10 to the negative 3 divided by 10 to the negative 2. Does that make sense to everyone? Kind of like we did the 12, we had 12 on the top and 4 on the bottom. We just separated them here. 3.8 divided by 5.1, I think that's going to, I think you could round that to 0.075. Will someone check that for me? That's right? Okay, we're going to round that to the 5. And now we have 10 to the negative 3 minus 2 power. So we have 0.075 times 10 to the negative 5 power. It started out in scientific notation. Is it still in scientific notation? Is this scientific notation? It's close. So what's this number going to be between? 1 and 10, right? So it's not big enough. So something, we're going to rewrite this. We're going to bring this down. So remember, if this is less than 1, is the exponent going to be positive or negative? If the number we're starting with is less than 1, is it going to be positive or negative exponent? Negative. Very good. So now the decimal is here. I'm going to go one place. That's 0.75. It's not big enough. Yes, 2 places. And now I've got 7.5, and I put my negative 2 there. Okay? And so now I simplify this. Like bases, I add the exponent. So it's 7.5 times 10 to the negative 7th power. So now I've divided two expressions written in scientific notation, and I wrote my final answer also in scientific notation.